Okay. Okay, on Zoom, can you hear me?
Yes.
Okay, cool. Perfect. Okay, oh my God, how am I gonna do this? Shoot. Okay, if you're on Zoom, what can you see right now? Okay, you just see the board still. Oh boy. Can I? Oh, shoot. They like went over this in our training and I don't remember anything. Oh. Let's try that. Oh, that's like backwards. Okay, now it's that one. Sorry, I'm trying to figure out Zoom. Oh. Okay, cool. Okay, so what I need to happen is okay, on Zoom and in person, I need you guys to either go to my website and scan this or try and scan it through your screen or copy and paste this link to sign in or something like that. So I'll give y'all a second to scan that or type that link in and fill out the information.
Are these sheets right here for people that are coming in today? Or are these from another class?
I think they're from another class, yeah. Okay. And then I'm gonna do this like warm up thing. Okay, cool. So now what I want to happen is if you guys on Zoom can join this thingy. It's totally anonymous. I selected it so that you can only view you can only select like computer generated names. But this is just like a warm up thing. I just want to know where you guys are in the class, how you're feeling about the content. So,
Where do we go to get that?
I'm sorry.
Where do we go to get that? Like, is that on your website?
No, you'll just type in this joinmyquiz.com and then enter this code. You can do it on your laptop or phone or anything. And I should have 8 participants.
Is there a link to sign in that we needed to?
Yeah, it'll be on my website. You have to scroll down a little bit and it'll have like a sign in
Okay.
thing, and there's a link you can copy and paste or scan the QR code. I've also never used this. I've always used Kahoot, but I think you have to like pay for short answer on Kahoot. So just see how this goes.
So do we get to your thing from the Canvas?
The website. I sent her an announcement to put out, and she's not. But the website is emilywatson01.wixsite, like WIXSITE.com/chemsi. 01.wixsite.com/chemsi. I can write it up on the board. Okay, I'm gonna go ahead and start this with 6 players. That's fine. It's also like not a right or wrong answer thing at all. I just want to know how you guys feel about what we're doing right now. And it'll help me make my test preps and things like that. Sorry if you liked the music, I didn't. And if you could go to my website and sign in with the link that's there, and that's the link to my website. How do y'all feel? And like people in Zoom land, don't be afraid to unmute yourself and speak. Hi, if you could go to that link, and then there will be another link on that website, and you'll use that to sign in. But how do you guys feel about chapter 2 so far?
I don't like it.
Mm-hmm.
She went really fast, and especially yesterday, I felt kind of dumb because I feel like everything just went over my head.
Exactly. That's true.
So
I
that
agree with
that's totally okay. It is a really fast class, and so like it's not you just feeling like she's going fast. She is going fast. Chemistry 1, there's so much to get through that it does go quite fast. Um, but y'all aren't dumb. Like y'all got accepted here. You're here for a reason, and it's because you're smart. So we're gonna get through this, and it'll be okay. And also, don't forget that there is one-on-one tutoring available if you feel like that's what you need. Um, that's available to you. You can call the tutoring center and set up an appointment. We can do face-to-face appointments Monday through Thursday from, I think, 9 a.m. to 4 p.m. But so if you want a face-to-face appointment, that's when it'll have to be. I'm not the chemistry tutor. I tutor biology 1 and 2. So if you're in either of those classes, hey, come and see me. It'll be fun. But I do know some of the chemistry tutors, and they're very good. So, okay. Oh, can I not see the answers? So this is most comfortable. Okay. Okay, cool. So there are some things on there that I've left off this time that I'll go over next week just to kind of keep us a little bit behind lecture. Just for some like wiggle room in case a class gets canceled or anything like that.
I missed the quizzes or whatever, but conversions and stuff like that, like different units and stuff.
Uh-huh. Okay.
I'm fine with, like, if it's going from like one thing to one thing, but if it's going from like kilometers to meters to centimeters, like just like when it's more like moved and out like that, I feel like I have more like trouble like figure out what I need to do and like how to set it up.
Okay. So the very first part of this handout is dimensional analysis. And kind of, I tried to make it go through like several stages because in chemistry, it's honestly pretty rare that you'll go from one thing to another. It's usually going to be like multiples. And it's also important to know that this isn't going to go away. Even in like OChem, I was doing stuff like this, like obviously different application, but still doing some dimensional analysis. Okay, so a circular room is measured to be 25 yards in diameter. How many inches is the diameter of the room? So for dimensional analysis, where am I going to start?
25 millimeters.
Mm-hmm. And I just leave it blank. You can put a 1 there if you like that. because it means same thing. Wow. My voice just went real country right there. Okay. 25 yards on top. What's going to go on bottom? 1 yard. What's going to go on top? 3 feet. On bottom
Feet,
and on top,
inches.
12 inches. So, what do I have to do now in order to? Not yet. This is a real simple step. Yes, cross it out because she'll dock points if you don't. And now it's 25 times 3 times 12 over 1. And what is that? Is this the answer that I want to report? No. Why? This has one significant figure. How many do we need?
2.
2, because that's what we were given. How am I going to make this into 2 significant figures?
Decimal.
How?
I guess we can.
So if I do this, we have 3 significant figures now. How are we going to make this 2?
Would it be like the 90 to the power of, or times 10 to the power of 1 or something?
Yeah, we're going to put it in scientific notation. And it's going to be 9.0 times 10 to the second inches.
We can put over how many times?
So you should always have only one number before the decimal.
And how do you know, or I guess, like, because I know, like, it's different, like, 10 to the whatever, but
Mhm.
is that, like, ones you have to memorize, like, which one goes, I don't know.
You don't truly have to memorize anything.
Well, why, because I know it can be, like, 10 to the 9, or, like,
Mhm.
stuff like that, so how do you know when to use which one? Is it if you're, like, the inches?
So
Giga and all that stuff.
Are you asking just how do you know how many, like the number to put
Yeah.
to the power?
okay. So for scientific notation, let's just go ahead and do 900. Let's stick with that number. So if I put it in 9.0 times 10 to the second, what that's telling me is I'm moving this decimal over 2 places. And if I do that, 1, 2, I know she said she doesn't like that, but that's what I do. So, whereas if you had 9.0 times 10 to the negative 2,
Bring it to the left.
you would have to move this 2 times this way. Because the way that I've always remembered this is it follows the number line. So like if you have 0 here and you have positives here and negatives here, if it's a negative, you're going to move towards the negative side of the number line. And if it's positive, you move towards the positive side. Does that make sense?
So if you're
Yeah.
going, like, which way is the negative for the exponent?
So if your exponent is negative, you're going to move that decimal towards the negative end of a number line, which is always going to be to the left.
So that's when you're moving the decimal to the left?
Whenever it's a negative. If it's a positive, you'll move the decimal to the right.
But you just move it to the left.
For that,
Yeah, but the 900, if you put it at the end, you moved it to the left, so why would it be?
so this is me taking it out of scientific notation. So like, ignore that real quick. So like if I were just given this, I could tell how to put it into take it out of scientific notation by moving it 2 times to the right. If it helps you to remember to put it into scientific notation that it's flipped, that works too. It's just whatever you'll remember best. Okay. So in the problem from question number 1, how many centimeters is the diameter of the room? So what am I going to start with here?
900, right?
Mm-hmm. What's going to go on the bottom? 1 inch. And what's on top?
Centimeter, which is
2.54 centimeters. And then you do math. And what's that answer?
397.46.
Is that what everyone else got?
Wait, what'd you say?
Why subtract that?
yeah, 2,000.
Okay.
Oh, 2,286.
2,286. Is this the answer I'm going to record? No. How many significant figures do I need? How am I going to make this 2?
You could you round down, right? It'd just be
Round it up.
So there's 2 ways you could go about this if you wanted to. You could write that, but most likely if this is a multiple choice question on an exam, she's going to give them to you in scientific notation. So what would this be in scientific notation?
2.3 times to the
To the
Sure.
third.
So if it's like that answer and you need like the 2 sig figs,
Mhm.
just like round it to the like.
Yeah, you'll just round it to where you get to.
Oh,
Okay. Number 3, how many minutes are in a week? So what am I going to start with? 1 week. What's going to go on bottom? 1 week. Just 1 week again. Really, you could just start at the bottom if that's what you like. I don't like that at all. I always start on the top, even if I have to repeat myself. So 1 week. Where are we going to go to next? 7 days. On bottom,
1 day, and then 24 hours.
24 hours.
And 1 hour and 60 minutes.
Mm-hmm. And always make sure you cross out your units.
So if you
And
don't physically show that step of crossing them out, you'll get points taken off.
yes,
Even if you end up with the right unit.
yes. It's more of like, because a lot of people that take this class have like a medical focus, even like vet med. So it's really all about sort of drilling in, like showing your work and being thorough. So what's the answer?
so after you like cross all that out, you do like the top, you multiply the top.
Mm-hmm.
So what would your sig figs be here if you're like, because we don't count conversion factors, right?
Right.
So
So
would you just do 1 so 1 week? Or?
this is kind of a weird question because you'll never see anything like this on an exam at all. It'll all be in like chemistry terms. So I threw this one in there just to have sort of a lengthy conversion. But for this one, I personally don't care about significant figures, whether you use them or not in this, just because it's totally practice in like learning how to do this process. So if we disregarded significant figures, what would it be?
Oh, it'd be 10,080.
Mm-hmm. So what if we wanted to use sig figs?
Depends how. Oh,
What was that?
it'd just be 1 sig fig, right?
Yeah, because this is 1 week is really what it translates to. And so it'd just be 10,000. Okay, are there any questions about dimensional analysis? This isn't the last we're going to go over it. It's just next time we do it, it'll be in like actual application. So, okay, history. Okay, number 4. Which experiment contributed to the discovery of the nucleus? Yeah,
Isn't it Rutherford's?
yeah, Rutherford's gold foil experiment. What did J.J. Thomson discover and how?
I think he discovered the electron, right? Or no?
Yeah, so
Plum
Basi-
pudding.
Huh?
Didn't he do like the plum pudding model?
he did the cathode ray tube. I'm pretty sure he is the one that came up with the plum pudding model. So basically, he did the cathode ray tube, and once upon a time, electrons were called cathode ray particles. And basically, he discovered that electrons are very small and very lightweight, and that they have a negative charge. Oh, shoot. Okay, how did Robert Millikan build off of J.J. Thomson's discovery?
You discovered the charge. but you don't
Yeah.
remember.
He discovered the charge of the electron. And this just means electron. What experiment did he do? We've knocked out 2 out of 3 experiments that we talked about so far, so. Yes, oil drop. Okay. Briefly list the blank postulates of Dalton's blank. Okay, so what did Dalton do? What thing did he come up with? It's like a list of things. Atomic theory. How many postulates are there? More? More? 5. There's 5. So there are 5 postulates to Dalton's atomic theory. So let's walk through them. Really brief, short, not going into a lot of detail. So 1. Okay, let me just start. Can anyone remember any of them?
What about the law of conservation?
You're not totally wrong. But you've Yeah, you guys like totally, I should have switched these 2 questions. So number 8, one of Dalton's postulates is a take on the law of conservation of matter. And here I'm just gonna put number 1 since that's the one you guys, it's last on my answer key, but it doesn't matter what order they go in. So I'll put number 1, and number 1 is that atoms are neither created or destroyed. anyone remember any of the other ones?
Atom's the smallest unit.
Yes. So matter is composed of atoms. These two kind of bleed into each other. So everything is made up of a series of atoms. Your pencil, your highlighter, your desk, you. And that bleeds into an element is composed of only one type of atom because an atom is the smallest unit that's going to retain the physical and chemical properties of an element. Once you break it down into protons, neutrons, and electrons, it loses those properties, and it's just sort of building blocks of an atom. Okay, there's two left. Does anyone on Zoom know any?
Compound.
What was that?
Compound. Like, what is it?
Is it an atom in one element is different from the atoms in another element?
Yes. And the last one is a compound is a compound is composed of two or more atoms from different elements. Are there any questions over any of that? Oh, okay, cool. Number 9, define the law of definite proportions. What is another name for it?
Definite composition?
Yes. It's also called law of constant composition. And she can use either term on a quiz or test. So know that they're the same thing. And what is this law? What does it say?
Pure compounds contain the same elements
Yes.
with the same mass.
So all samples of a pure compound contain the elements in the same proportion by mass. So that's kind of like a wordy definition. So how many of you feel like you can memorize that definition, but you don't actually know what it's trying to say? That's fair. That's very fair because it's how I felt too. So what it's saying is, let's say I have, oh, this is weird. Let's pretend this is like a syringe and not a marker. And let's say it's full of water. Well, all H2O molecules have, okay, how do I want to put this? The percent by mass of oxygen in one molecule of H2O is equal to the percent of by mass of oxygen in a syringe of H2O. And it's equal to, if this were full of H2O, same amount of oxygen by mass, percent by mass. Is that still confusing? I feel like that was still confusing. Okay. So let's say that I'm totally pulling this out of like nowhere, so don't take this as fact. Let's say that in a single molecule, oxygen is 80% of that molecule's mass. Well, in this, if it were full of water, oxygen is going to make up 80% of the mass of water in here. Even though there's a different amount of water present, there's a different number of molecules, that composition stays the same. And then in this, it'd still be 80% water by mass. Or, sorry, 80% oxygen by mass.
Could you go over that again, please?
Yeah, I can. So, let me think of a different example. Okay, let's say you're like trying to make cornbread or something. You go to the store and you know how they have cornmeal with flour already mixed in? So there's two different size bags, right? Like you can buy a small bag or you can buy a big bag. If you buy that small bag, maybe it's 80% cornmeal, 20% flour. Well, even if you go up and you get more, there's more mass present, it's still 80% cornmeal, 20% flour.
So it's a fixed percent ratio.
Yes, that is a perfect way of explaining it.
Fixed ratio, that was.
Yeah, that's great. A fixed percent ratio by mass. Does that make more sense, person that asked on Zoom? I didn't see your name.
Yes, thank you.
Okay, cool. So I don't know why I decided to switch to fill in the blank in the middle of the worksheet, but I did. So the law of blank states that when blank elements react to form blank compound, a blank of one element will react with the masses of the other and a blank of blank blank numbers. So we talked about a few different laws. We've gone over a law of constant composition and definite proportions, which are the same thing. What's another law? It kind of has a similar name. It's dealing with the same kind of thing. Nah. Multiple proportions. So the law of multiple proportions. How many elements are going to react?
Two or more.
Two or more. Let me find this. So I'm going to stick with two because I pulled this straight from the PowerPoint. And what are they going to form? Compound. How many? Yes, more than one. A blank of one element or a what of one element will react with the masses of the other element. This is a weird question. I'm just going to give it to you. It's mass. A mass of one element will react with the masses of the other element in a blank ratio. Ratio of small whole numbers. Okay, so really, this is starting to address like writing out chemical reactions and balancing them. Whenever two things react to form more things, like what happens in a chemical reaction, those numbers in front. So like, let's say you have that's the type of reaction we'll learn. But basically, these have to have, this is incorrect. Don't write this down. I didn't have time to think of a good one. But these numbers out in front, whatever is out here, it has to be a ratio, so they have to be equal to each other. And that's why I say don't write this down, because this is not equal. But they're the smallest they can possibly be. If it's 2, 1, 2, 1, you can't get smaller than that. Whereas if it were like 2, 4, 2, 4, you have to reduce that down to 1, 2, 1, 2. Does that make sense? If these are multiples, if they can be reduced, you have to do that. So you want to get it to the smallest number possible, and they have to be whole numbers, no decimals or fractions. And that's an issue you will probably encounter. But we'll learn how to fix it when we get there, so it's okay.
Not the same as when she was talking about like going from molecular to an empirical formula, or is that different? 'Cause
Yes.
that's subscripts. Sorry, my mind gets kind of like ahead of itself.
No, you're good, you're good. I don't totally know how to answer that question, but it's the right concept even if it's not the right application. Okay. So we talked about different types of radiation. How many types were discovered? 3. Who discovered them? His name's come up already. Ernest Rutherford. Oop. What are the different types of radiation? Alpha? And what is alpha?
Protons.
Yes. What's another?
Beta.
Beta. And what types are these?
Electrons.
Negative. And what's the last one? Gamma. What types are these? Neutral, no charge. So, positive, negative, neutral. Where else do we hear those terms? Subatomic particles. So what does this tell you? What does this tell you about radiation? It's an atom breaking down. Which one of these are going to hurt you a lot? Gamma. How do you guys know that? I know it from the Hulk. Yeah, that's a good one. I just remember it because of the Hulk, like gamma radiation, made him. Okay, so moving on to isotopes and isomers. Okay, wait, pause. How do you guys feel about the history portion? She said she's not going to hit on it too hard on the test. That's what she said yesterday, right? So I kind of went in depth so that way whatever ends up on the test, you'll hopefully be prepared for. But how do you guys feel about that? Is there anything that you're like, whoa?
I feel like it's just memorizing it, kind of like just normal history.
Yeah. Okay, isotopes and isomers. We didn't really talk about isomers, but she's not the type to do trick questions, but she's also the type to, if she's asking for a definition, she will put isotopes and isomers both as answer choices because they sound so similar. So what's an isotope?
Element with different number of neutrons.
Yes, neutrons.
Yeah, those two things confuse me, honestly. I like that.
So isotopes are atoms of the same element that have different masses. And you actually answered number 13, so I'm going to do that real quick. What allows the mass of an atom of a particular element to vary without changing the charge in its neutrons. This is because they're equal to 1 AMU, 1 atomic mass unit, and they're neutral, so they're not going to mess with the charge of an atom. Where was I? Okay. So an isotope So atoms of the same element that have different masses. What about isomers? What are isomers?
The same thing but have the same masses.
Kind of,
Sort of, but no.
sort of, but no, yeah. She like mentioned it super brief, so like I don't blame you guys for like not remembering that because she like said it and then she was like, okay, next slide, because it's not super important in this class. But like, how many of you guys have to take organic chemistry?
Say how many or do we?
Yeah, do you?
Yes.
Isomers are really, really big in organic chemistry. Like huge. You're gonna spend like a whole month talking about them. So an isomer, these are compounds that have the same chemical formula, but different molecular shapes. So this is me working off the assumption that most of you guys are biological science. If you're not, don't worry about what I'm about to say. But if you're biological science, you're likely just taking chemistry because your major requires you to. And one way to think about this is proteins, enzymes. Once their shape changes, they don't do the same thing anymore. They're useless. And because different shapes have different meanings in the body, it's the same with chemical compounds. So you could have the same chemical formula like C6H12O6 and have it one shape and it'll be useful in the body. If you change that shape but keep the same number of atoms, it can harm you.
What's the name of that element you just said?
I'm pretty sure it's glucose, right?
Yeah.
Am I right? Okay, cool. So isomers, compounds that have the same chemical formula but different molecular shapes. I'll put an example in here. I'll do glucose, even though I'm not going to draw it right at all. I'm going to make something up. Okay. Then we did 13, 14. Break down the structure of an atom and its subatomic particles. So what I want to know here is, where is each subatomic particle found? Which occupies the most space? And what's the heaviest part of the atom? So where are protons found? In the nucleus. Where are neutrons found?
Nucleus.
Nucleus. Where are electrons found? Electron cloud. So I'll just like draw this. Is the nucleus big or small compared to small? So here we're going to have protons plus neutrons. Now here we're going to have electrons. So you want to know that nucleus, heavy. This is where pretty much all of the weight is found. And the electron cloud, big. It's really big. Electrons take up the most volume in an atom.
Wait, what did you say, Dave? The electrons?
Yeah.
Wait. Because there's so many of them compared to, or
Just because the nucleus is super small and electrons, remember that they have the same charge. And when you try and put two negatives against each other, they don't want to go. They want to spread out as much as possible.
so you're saying like they occupy. Okay, I misunderstood.
Yeah, they just occupy the most volume. But pretty much all of the weight is located at the nucleus. Okay, we're almost done, I promise. We have 3 questions left. So how is an isotope symbol set up?
The element symbol, and then like the
Mm-hmm.
mass number in the top left, and then the atomic number in the bottom left.
Yes. So we have mass number in the top left, atomic number in the bottom left. Oh, shoot. Sorry, guys. So what's the difference between a mass number and an atomic number? Yes.
And the mass number is the atomic number plus the number of neutrons.
Yes. So another important thing to know about the atomic number is that it will always be the same for the same element. So even if you have two different isotopes of carbon, that atomic number is going to be the same. The reason this is so important is that it talks about protons, right? The second you change the number of protons, it's no longer the same element. And then mass number is protons plus neutrons. And it varies. Okay, last question, then I'm going to add something to another question. Isotopes can have a charge, true or false? True, they can have a charge.
Don't they like have to, or else it's just an element, or not
Mm.
necessarily?
They can be neutral, but they can have a positive or negative charge. So where on our isotope symbol will we denote that? Top right charge. And then isotope charges, next time I'll put a small section about figuring these things out and working with them. But yeah, that's all I have. Does anyone have any questions? Did everyone sign in?
Yep.
Okay, cool. Is everyone on Zoom good? Any questions? Everyone signed in?
So you were saying like next time you do like an example, because yesterday she was talking about like, I don't even know how to explain it, like the different like numbers. So if you have like a negative charge, you would take one off of the protons or something, and like that would change it.
Two negative.
Yeah.
Yeah. So
I'll
you-
do that next time, like
Okay.
working with isotope charts that she'll have on the exam and with charges and things like that.
Okay, thank you.
Okay, if everyone's good, I'll go ahead and end this. Okay, bye.
Thank you.
Thank you.
Mhm.